Good afternoon, folks. Thank you for attending my comedy special today. Okay, wow, tough crowd. I guess the sugar's still kicking in for me. I hope it does for you as well. I'm Vignesh. I'm a PM on Azure Storage. I work on object data management products. Today, presenting with me is also Shruti.
I do have a caller mic. Hi, folks. This is Shruti Sethi. I'm also with the product team with Azure Storage, mainly focused on everything that is end-to-end cost efficiency as well as carbon efficiency. And that's sort of where this comes in. So presenting with Vignesh.
So today we're going to cover, everything from understanding the cost challenge in cloud storage, as well as some practical techniques, some blind spots that, that we're seeing as patterns across the industry, and going down towards some solutions ranging from simple tiering to some AI recommendations. So let's jump right into it with the challenge, right? The exponential data growth in modern organizations has simply created the ubiquitous question or challenge of how to store vast amounts of data cost effectively while keeping in mind the performance and their accessibility. And as companies migrate towards cloud-first or hybrid cloud strategies, storage cost often represents a large line item in their cloud storage bills, often ranging from 10 to 30% in most organizations, and in data-intensive organizations, this can jump up to about 30, 40%. And as you can see, the trend is that this is only going to grow more at a 10% CAGR. The root cause, though, isn't just about the data sitting in hot, expensive tiers, but also in the management of it. The operations that are reactive, one-dimensional, time-based policies with little insight on the data that is being stored, or don't consider the downstream impacts and effects on the applications or the charges that come along with it, are what often snowballs into these large storage bills. So the understanding of this problem has brought about the evolution of cloud-native solutions for your storage to operate on a spectrum of costs, cost structures, performance capabilities, and access patterns. So the question is, where do we begin? And the obvious answer, storage tiering. Tiering helps align each data set with the right storage class based on its performance needs and accessibility. The cost differences between each of the storage tiers are quite significant. The hotter the tier, the higher the storage cost, but the lower latency in access and the lower access fees. In contrast, the cooler the tiers, as you go towards archive, you're now paying much cheaper. It becomes much cheaper, and you're paying only for, you're trading off with the retrieval times and the latency over there. One other aspect that we see customers often miss is the cooler tiers have a minimum retention period, right? So moving the data out of the cooler tiers earlier than this retention period often comes with a penalty, which we term as the early delete penalty. It's basically the rent due for the rest of the period, right? So by understanding these tiers, their cost, their performance, and their principles, right, organizations can craft a storage approach that's meeting their performance needs at the lowest cost possible. So a multi-tier strategy helps us enable storage that is cost-effective. And you may ask, okay, how do I know when it's worth it to move data from cold to hot or to other tiers? Let's do some simple math on 1 GB of data or one object stored, right? If I'm storing 1 GB of data in the cold tier, my minimum retention period for that is 90 days. But let's assume I had cold feet the moment I moved it to cold, right? I have a maximum deletion penalty of 90 days, which is about 2.4 cents. And every object I move back to the hot tier or a tier out of cold, I incur a transaction charge, which is about 0.01 cents. So a grand total of 2.41 cents, right? This is just the penalty that I'm incurring for moving data out of cold if I move it within the first 90 days or on the first day of the 90 days. On the contrary, if I had left the object in cold, I would be able to do 1,854 read transactions and 462 write transactions. This is for one object of size 1 GB. Now, the same thing, if I expand it to multiple objects at an average size of 2 MB per object, I'm now doing across the board at least 5 reads or 2 writes per object if I'm averaging that out. So in a sense, it makes sense depending on your workload as to whether you leave the object in cold if it works out to be cheaper, or if you actually have to move it if your workloads require more writing and more reading of the object. Now the question comes down to, okay, I have billions of objects, if not trillions. How do I do this math? Why do I have to sit and do it for each and every storage account? How can I automate the whole thing? Which is where Shruti comes in.
Okay. So now that we are aware that we want to move tiers based on this analysis of our object and what GB size it is, we're not expecting that the user is actually going to sit and do that manually for everyone. There we bring in policies, which are like the fundamental way that tiering is done. So policy is nothing but a set of criteria or rules that the user can establish. Say, for example, I want to say, once my object is 30 days old, tier it down to cold. It's a simple policy. So it's a set of rules that the user can define, which then are applied or evaluated on each of the object. And once it satisfies the criteria, a decision is made to move the tier or not move the tier as may be applicable, and the action is taken. Resultant, you end up with your objects being well tiered according to how good your policy is into the hot, cool, cold tiers over there. Another thing that the policy approach gives is that it allows you to reevaluate. So note that as your data gets older, it may not have the same characteristics. So having a policy allows you to reapply the policy easily and reevaluate what is the correct tier for it. So not having those static characteristics all throughout the lifetime. With this being the policy that is a fundamental thing, there is more automation on top of this to help the users. Vignesh, you want to explain it?
Sure. So in terms of automating these policies, there's two approaches you can take. One is with data management policies, where you know your access patterns to some degree, you know the objects to some degree that you want to tier, or you know where you want to house them. And there's a gamut of tools available that you can use depending on your workload's complexity, the operations that you want to perform, and the precision with which you want to find these objects, right? So in the case of manually creating these policies, you have tools like blob lifecycle management from Azure as well as from Google. You have Azure Storage Actions where you have more precise policies. And these tools, generally, you're just paying for the transaction fees. You're paying for some early delete penalties if it is applicable to you. But there's no overall management fees. And here you have full control on the performance and the access tier you want your objects to live in. The second approach is with intelligent tiering, where you've given complete control to the cloud service provider, where they determine where your object lives, how accessible it is to you, based on your access patterns that they have addressed and analyzed. Intelligent tiering capabilities like Google's AutoClass or AWS's intelligent tiering provides you these capabilities at a management fee, either at the blob level per object managed, as well as the management of each storage account. And the cloud provider over here manages all your the early delete penalties or tier change transactions. None of that is charged to you, but the cloud provider is the one that manages which tier your objects live in. So let's take a look at how you can create an objects management policy with data management tools that are available today. One of the tools I'm going to walk you through is Azure Storage Actions, which in this example scenario, I'm walking you through the autonomous vehicle development process, which generates tons of data, be it vehicle data from the sensors, from the cameras, from the LiDAR, vehicle telemetry, driving scenario data. All of that is generated just by one car, which can be in the petabyte scale. And just for example, let's take a look at this one container in which all of this data is being dumped into from your vehicles on a day-to-day basis, and it's just accumulating, right? You have log data, you have a plethora of data types and indicators as to when the recording was captured, what sort of recording it is, and a lot of metadata with relation to all of the files. Right, but this mix of information is not yet ready for any sort of model training. Right, there's not any categorization that's been done so far, and this is where developers can use tools like Azure Storage Actions to create policies from the start. Where in this scenario, I'm looking at every file that's not a log file created less than 7 days ago, contains the word city in it because I want to create a city driving collection, and anything that's larger than 1 GB. All of this being targeted in my list of billions of files and put into this collection with blob index tags saying long city drives. This I can then later on use for model training, right? A second task I'm creating is based on my GDPR or autonomous vehicle regulations, where I'm looking at log files. I need to make sure that I've last accessed it less than 7 days ago. And then I'm moving it to cold and applying an immutability on it as per regulations. These are two tasks now that I can apply to multiple or assign to multiple storage accounts, giving it the containers that I want to specifically target or specifically exclude, and I can run it on a particular schedule based on my business needs, be it a daily basis or be it a one-off run depending on my situation at that point. Right? And we're not yet done. This is just the early stages of the workload where we've ingested data, we've got a tool in place that can start cost optimizations for us right from the beginning. And then this data, where be it collections of your driving data, be it the data, be it your telemetry or be it your logs, all of it that you need is stored in the right tiers, in the right access points, which then goes through your entire workload of model training, vectorization, et cetera, which brings out your simulation outputs, trained models, and then you can create another storage task to actually take that data and tier it according to your relevancy as well as requirements of further downstream processes. The benefits of using such a tool would be that you have begun early cost optimization with left shifting the classification and categorization of your data before it sits in your storage account waiting for time-based policies to take effect. So the early data classification helps, as well as storage actions specifically being a no-code, serverless, scalable tool accelerates your, pun intended, accelerates your cost optimizations, as well as makes it a much easier process with little to no manual overhead because of the automations in place. So now this covers a few of the blind spots and gaps with one tool. Maybe let's take a look at more of the blind spots. Shruti?
Yeah. So let's particularly talk about only pitfalls and blind spots for some time. Okay, these are what hit the users the most when they are planning of doing tiering. So I'll talk about it in two buckets. The first bucket related to the access pattern and the characteristics of the data. So first and foremost, and like the most important aspect, is having the visibility and monitoring abilities in order to see the insights of how your data is behaving and what are the characteristics. We'll come back to this point actually once more in later slides, because this is probably the most essential foundational piece that is needed before you can do any tiering. The second part is, once you have a visibility into the data characteristics, assuming that these characteristics are going to be static, which means are going to remain same for that object throughout the lifetime of that object. That's the second piece of pitfall that we hit. Thirdly, we normally think about how many writes, how many reads, how many other transactions, etc., are happening, but we are not always thinking about how much of metadata access do my objects go through before making decisions of tiering. Fourth is something that my colleague here also hit upon in his example, in his first example, delete patterns. We might look at how well or how less the data is being accessed, but we may not be looking at how quickly does this data get deleted, right? And because the lower tiers, cold tier, archive tier, these have retention policies, not being able to assess the delete pattern might mean that we move it to these cooler tiers and then hit a penalty because we did not actually stay in that tier for the entire time frame. It's like a one-time lease that we break early. Okay. The last two more things to keep in mind about the access pattern. Not only think about the number of transactions, but also how much egress, how much data is actually being moved or accessed over here. And then think about that data being retrieved. How does it affect the retrieval time? In some of the tiers, like archive tier, you might be hit with some hours of delay in getting the data back. So does that affect your application? Okay, so all of this is one bucket of pitfalls that we can fall into. Everything related to how the accesses are, how the data pattern is. But there is my other bucket, which can also be blind spots and pitfalls. So some very common ones over there is, suppose we are setting up multiple policies. So I'm setting up one policy to tier down to cold. Maybe I'm setting up another policy to tier down from hot to cool. Having misalignment between the policies can lead to conflicting results that might surprise you when the bill arrives. Yeah. Secondly, keeping in mind what is the blob size in the object being tiered. So when you tier an object, there is a charge incurred. It's resources used to move your tier, and there is a charge incurred. We have to be mindful of the fact how much data is actually sitting in that object. Am I benefiting by moving it to cold, or is just the activity of repeatedly changing the tier sort of overpowering that benefit? Third, and I think the third one is a growing problem as we are exploding on data. More and more data is getting stale, and there is sometimes lack of ownership. Data is left untiered just because there is ambiguity about the ownership, which means unnecessary high bills. Okay, fourth one. I think fourth one I just refer to also right now. When you're actually doing the tier change, there is a cost incurred. Sometimes we forget to include that in our analysis. So we might be looking at, okay, what will be my total outcome cost if I store this data in cold? But also think about, if I'm moving these many objects to cold, what is the cost of actually moving it? What is the cost of moving it back if needed? And lastly, depending upon how your application is, changing the retrieval duration time or change of location because the tiers change might have some compliance implications to your particular application. Okay, so we looked at a lot of pitfalls. Now consider that we have some data. We want to introduce tiering now, right? So I already have my data stored. I want to introduce tiering. There are certain few cases that we have seen where users sort of get hit by things that could have been avoided just simply because the data already existed and tiers are being introduced on top of that, or you're tier tagging at this point. The first very common one goes back to the retention policy. So suppose I know my data lives for 100 days. There is a cold tier that says retention policy of 90 days. I'm happy, my data is appropriate for cold tier. Okay, I'm going to move it to cold tier. This is when I introduced the tiering, I moved all my data to cold tier. But keep in mind, some of that data might already have lived part of its life. So suppose it's already lived 20 days out of its 100 days. You're actually going to hit 10 days of penalty over there. So the overlap of retention time and when the policy or when the tiering was introduced is a very common aspect in the initial tiering phase. Secondly, suppose I have tiering, but now I want to introduce intelligent tiering. Again, an important part to keep in mind is, what is finally going to take effect? Do my manual tiers that I already established, are they going to take effect, or is intelligent tiering taking effect? This is all, again, so that you're not surprised by the resultant outcome, right? Because there is one tiering, you're introducing a second form. A third level is, when you're initially going into tiering, sometimes we high level the analysis in order to figure out whether this is beneficial or not. Now with tiering happens at a blob level. So it gives you a lot of granularity, lots of control. But sometimes in the analysis, we might consider all the data that is maybe in an account, in a subscription at a higher level, which may indicate that it is beneficial to keep it in hot. But in reality, there might be pockets which will benefit a lot by moving to cold. So the level of analysis sort of becomes very important when you are analyzing where to go for tiering. Okay. The next, this is not a pitfall, of course. This is a growing need that we would like to touch upon. Since AI workloads are very heavily using storage right now, and tier optimization is very important for those AI workloads simply because they are extremely cost sensitive, right? Who wouldn't want to reduce cost? Who wouldn't, by the way? Anybody? Okay. So having tier optimization as a very important aspect that can help with the AI workloads. Somebody's not happy. So during the entire life cycle of AI workloads, different data sets are going through different stages. So you might have like the first stage where you're doing training and tuning, massive data, extremely sensitive to accesses because your compute or GPU pipelines are going to incur you a high bill on delays, right? Then you might have model inference stages where you're accessing your model parameters. Depending upon how big your model is, there might be a less or more amount of data that is getting accessed there, still needs fast accesses. There might be a stage where you are long-term storing your training data, not actively getting used for another training until maybe you are training the next version of the model, right? So that gives you the opportunity to actually use tiers for storing this data. While some might be stored in premium and hot tiers, there's data that you can consider for hot, cold tiers also if you're storing it that time for not active training. Okay. So there was one blind spot or pitfall that we said we will come back to. I just wanted to highlight this one because this is the foundation of being able to do tiering, that is having your monitoring and visibility ability over there. There are a number of tools the cloud providers in industry have sort of made available right now. Some of those are Storage Lens from AWS, Azure Monitor or Azure Storage Discovery from Azure, then Storage Insights from GCP. These are all sort of trying to make sure that the user is able to see the insights and make an informed decision about their tiering or tiering policies. The key thing with some of these tools is not only looking at the metrics, but also being able to set alerts to understand when A, characteristics change, B, maybe some wrong tiering happened, there are bill spikes going on. So these are all helpful features that can help you make sure that tiering is done well. Of course, coming up, there are more and more AI recommendations that are also getting embedded into these tools. We have a session actually on Wednesday by our colleagues Akshay and Preeti over here that will particularly go into some of the tools that Azure provides for these monitoring and visibility. Do not miss it on Wednesday afternoon. Okay. With that, I'll actually ask my colleague to recommend what are the best practices to follow now.
Right. Thanks, Shruti. So we covered a lot of the blind spots. We covered a lot of the tools that we can use. Let me recap our best practices and elaborate on a few of them. So obviously, early data classification and tagging is very important. Identifying which tiers your data is going to sit in from the time of upload is going to save you a lot of money, right? Uploading infrequently accessed data to directly into cool or archive tiers will avoid your unnecessary hot storage costs. Enabling lifecycle policies to automate data movement helps you transition objects based on last access or simply the age. If you want to get more complicated, you can implement tools like the storage actions or AWS's batch, or you can even go further with the intelligent tiering services. because all of this helps with little to no manual oversight, which means more time to do actual development work, less time managing costs on this. As an example, there was a cloud native SaaS provider we were working with who was able to save about $500,000 a month from applying lifecycle management policies to about 30,000 accounts they owned on Microsoft. And this was just within 2 months of work that they could get all these savings done. Regularly review your storage metrics with all the tools we just mentioned. Using advanced analytics and AI recommender solutions helps you identify the trends, the anomalies, identify the buckets with relatively less access data, but it's sitting in hot. And then you can sit and adjust your lifecycle policy rules based on the information that you're seeing in these dashboards. Optimizing retention periods based again on your access and your expiration rules can automatically delete the data for you, so you don't have to sit and manually do it. This also reduces any sort of storage costs and liability. But while doing all of this, make sure you're piloting your lifecycle management rules on smaller data sets before you start affecting your entire data estate, because some of these mistakes can be irreversible and quite expensive, and we know that from experience. From the beginning, right-sizing your infrastructure is also another great way of saving costs on storage. Just being able to provide reserved capacity can save anywhere between 35 to 60% in costs for your storage. Compressing data is another great way of doing it. Shruti spoke about size-based tiering and how smaller objects can be expensive to move down. Leaving it in hot is probably better. Deduplication also falls in the same bucket, so you're not moving multiple files of the same category or the same type, of the same value down to multiple tiers. And then finally, conducting regular audits using AWS Lens or Storage Discovery would help you stay on top of your storage data estate and help you save costs at the same time. Let's take a look at what the future holds.
So we are trying to leave you with some food for thought, and pardon us if some of this seems far-fetched or you are like, no, this is not how tiering is going to work in the future. That's fine. But just some of the ideas, concepts here for food for thought. First one, of course, like storage tiering getting more and more AI focused, having more and more AI recommendations, so that users have to handle less. That's, I think, an approachable future that you see. The next three, a little bit more futuristic. So think about, for the second one, think about, I spoke about policy, and I said maybe I want to set up a policy that if my object is 90 days old, tier it to cold. But suppose I want a very high-level policy. Like, I don't want to specify how many days, etc. I want to say, tier my data to give me best performance, or tier my data to give me lowest cost. That's an intent-based approach. Maybe that's where the tiering domain evolves. The next one, of course, I'm a very big proponent of sustainability, and it's a growing need in the industry too. So greener tiers, sort of making sure that storage media-wise and energy-wise, the tiers are able to optimize that for the users. Maybe consider even not just the accesses happening, but when are the accesses happening? Are the accesses happening at a peak usage time of infrastructure or off-peak usage time of infrastructure? Maybe that plays into a role for tiering. And lastly, just something to think about. Maybe we want to take multiple of these aspects into tiering. So maybe it's a holistic score. So with various of these different aspects coming together, there is a scorecard given or a score given to the object. And based on that holistic score, the tiering is decided, and whether it goes into a higher or a lower tier comes out of that. So these are just some food for thought. We would love to also hear what others think tiering can benefit, or how do you, if you are a user, how do you see would benefit you if something was there with tiering that doesn't exist today. We'll just leave it with this word cloud for you to see and open it for any questions, anything you would like to bring up, thoughts on where tiering can go. Yes. Should I bring a mic or?
No, good. So, I mean, you guys, what I'd really like to do is be able to arbitrage across multiple cloud providers, say you at LMNOP, and use that model on another upper layer so that I'm treating, if I want to store cold data, I can go to somebody else, or if I want to store the cold data with you and do my processing on somebody else. How far away are we from that? Is Microsoft going to support any of that?
I'm smiling because it's such an interesting question.
I'm smiling behind my mask.
Yes, I can tell. You want to answer?
I don't know if,
Is it technical capability?
yeah. I don't know where anywhere at this point I can talk about where multi-cloud support is available yet on Microsoft. I know we have services where you can bring in data, but to have your data live in a different cloud and do compute or whatever other activities on a different cloud, I don't know if we have that capability today. I'm not sure if there's any other cloud provider that has that as yet. So maybe we are a couple years away from that, as far as I know.
It's an opportunity for a business, right?
Yeah.
Or if it doesn't already exist.
I mean, one important thing that what Vignesh is also hinting to that comes into picture is that then you're actually moving data between infrastructures that are not already, I'll say live connected kind of thing. So, there's going to be a cost associated with that. So a different type of cost that has to be evaluated. It's also that the user has to then evaluate, hey, am I still going to benefit by doing that because there is this additional, probably a good chunk of cost coming.
Very high.
Yeah.
Yeah.
Yes, but you could also have a meta model that sort of assigns tasks to your model, your cost optimization model, and then I can also look at the cross-cloud costs and benefits and latencies, et cetera. This is great work. This is what we're looking for in this trackers. Thank you.
Thank you. Sorry.
I was curious if there is any technical reason for early delete penalty. Because as a customer, business-wise, I understand, of course. But like, for example, if, me as a customer, I'm going to stay with you guys in Azure, and you're just moving me from from cold to, let's say, cool or hot. What's the technical reason for early delete penalty?
Yeah, I can maybe take that one. So think of it like when this certain amount of data is indicated or signaled as cold to the provider, we might be doing some optimizations on the data. Maybe we are doing some kind of erasure coding. Maybe it is getting stored on particular, dense systems, etc. And there are resources that get spent in order to do that optimization or do that erasure coding, etc. So then the cost of spending those resources is sort of retrieved by, okay, at least for this long it stays there. Because if it is jumping, then we are spending resources to optimize, unoptimize, optimize again. So that's where it basically comes from.
I would say there's other reasons beside that. And those reasons would be to just drive discipline at the user level. You look at your cost reductions. You don't want somebody taking hot data and sticking it in cold tiers so they get a good price and then bouncing back up without a penalty. Otherwise, they won't discipline themselves.
Yeah.
Can you talk about your deduplication and your compression and how does that impact storage costs? What costs are involved with the deduplication? Are you charging for the data undo or post-dupe? And compression, how does compression tie into those?
You want to talk about deduplication?
Sure. In terms of deduplication and compression, right? We were talking about the size of, or the number of objects and the size of the objects, right? The smaller the object, if you're tearing it down, you're paying more for the transaction charge than actually just storing it in hot tiers, right? So that's where the deduplication and that's where the compression really comes into play. Yeah, I'm trying to think how else I can explain this if I'm not making
I'm
it.
just curious, am I paying pre-dupe, pre-dedupe, or post-dedupe prices, right? Because it's capacity.
So Yeah, you're paying for how much you're using.
Yes.
Duping it to optimize yours.
Yeah, so one thing is like erasure coding or compression, like all of these different kind of optimizations. The reason you are able to get a lower rate is because some of these optimizations are able to help us save, and we are passing on the savings. So essentially, of course, the user is, you will see the charge based on what capacity you're using, but you're just seeing a less per unit charge. And that's essentially coming from all of these optimizations that are going on behind the scene. Is that, yeah.
Can you back up one slide? So this one's kind of interesting to me. I mean, the way I kind of sort of internalize it is sort of an AI recommendation is, here's what I think you should do based on the outcome that you want. Intent-based is actually taking action. Greener storage seems like a variation of intent. Holistic scoring. So I guess I'll focus in on the intent.
Mm-hmm.
How do you envision this in terms of like a single overarching sort of prime directive? Or if you have the ability to specify kind of multiple intents, because that's kind of a compelling way to think about managing storage. How do you not get into a situation, politics aside, like the Fed, where it's got to minimize inflation and maximize employment, and sometimes those are actually in conflict with each other. So how does that kind of intent-based tiering, how could you imagine it working without getting into some of those conflicting situations? I don't have an example, I'm just curious.
No, very, very good question. And I guess, so just to reiterate, you are asking about if there is actually an intent-based tiering, or if the domain, the industry does sort of evolve towards that. How do we see that different intents might conflict with each other?
Yeah, you can have it fast, you can have it cheap, or you can
Yes.
have it, but you can only get like one of them or something. So, how do you, if I want to maximize for performance, but also maximize and optimize for cost, those are likely in conflict with each other. So,
Yeah. So certainly don't know how this will pan out for sure. Like, if it will pan out. I certainly don't know that. I don't claim to know that. But just, initial thoughts on that. There is a little bit of, sort of being able to prioritize what is the highest intent. I think what would very heavily play in is from the user point of view, what needs to be signaled as the highest intent in that case. Now, the user, of course, has multiple intents that they might be looking to satisfy. I get that point, but there might be some user prioritization needed over there, because then it can, you're right, if you have multiple things specified, it's going to result in unexpected outcome of that tiering. So,
yeah,
certainly very.
It also seems very aligned for an agentic workflow for policy tiering. And then you can have agentic wars.
Yeah, depending upon what is it that the agentic model needs to accomplish. Sure, yep.
Do you have a pre-onboarding Azure discovery? So all my data is on-prem, but I intend to move to Azure storage that would classify at least the data before I actually move, so I can move to the correct tier instead of moving out to hot tier and then starting
Correct.
to go back.
I believe there are services that we provide wherein you can preset the tier before you move it.
Yes. Yes. You can set the tier when you move it.
You want to do the analysis on-prem before you move it.
30-day, 60-day analysis prior to move the data. So I know, I know the behavior of the data, because on-prem most likely it's a single tier. And now you have all those different tiers that I can play with to maximize cost or maximize my
Benefits.
Which on-prem not nobody, but it's very rare that I think about it, because it's a single performance tier and a single cost tier. But now I have this option. Otherwise, either I pay too much at the beginning, and then I learn now I need to optimize, or I put the wrong tier in my performance servers for a couple months, you will discover, well, I'm a little bit wrong too. It would be good to have these like 60-day analysis, 90-day analysis prior to move.
Right.
I think right now there isn't something that would be able to do that. And the main restriction is because, of course, the service that you're moving to, like for example, Azure, if you're moving to, Azure doesn't have visibility into all the data patterns while that data was sitting on-prem that is owned by somebody else.
The same idea
So,
that you apply to the customer storage account. You
Yes.
could create a service that the customer uses locally to assess that.
Yeah, I do know there are open source tools that you can use. I'll have to get back to you on the Azure tools. I have an
Yeah.
inkling, but I'm not 100%.
No, that's fine.
I think this is kind of touching on your main point, observability. And so you may have a workload or application, but we don't know how the math and calculus is going to work for enforcing or getting a certain SLA. So given this workload or this data set or however, this set of objects, however it gets tagged or grouped, being able to get that observability that right now I'm paying for this much service and I'm only using a third of it, or whatever. So being able to get the observability on the cost with all the calculus, all the data movement, all the tiering and the in and outs and all that, that's still pretty opaque.
for the data that's currently sitting on-prem and wants to move in.
Well,
Or
even
it's getting-
in the cloud. In
Okay.
the cloud,
Okay.
it's relatively opaque on, do I have this on the hot tier and I don't need it there? And the real-time metrics to say Tuesday, Wednesday, and Thursday, you're underutilizing, you're over-provisioning the quality of service.
Right. Actually,
Yes.
that's actually a perfect segue to the next slide that we had, where we wanted to ask you to go check out a couple of the other sessions, which precisely talks about the data management and the observability of the data
Yeah.
living in cloud. So that session, we have Preeti over here, who is going to be conducting it with my other colleagues. And then specifically for AI applications, RAG for AI applications is another session, both of which are happening on Wednesday. So you can get more deeper insights on those specific questions in these sessions.
Yep.
Any other questions?
Yep. One guideline, just to make sure everybody knows, some of the sessions we have to move around, so please check the monitor by the front.
Right.
When you go to the room.
Yes.
Yes, please check the monitors as well.
Yes.
All right.
Okay.
Thank you so much, folks.
Sounds like a wrap. Thank you.